Okay, continuing on. If I write this now, one, two, one, two, three, one, three, negative one, negative four, and a 6, 4, and a negative 2. So my first goal is to make this a 0 and this a 0. Well, let's see. Let's use colors like we did on the previous. To make the first a 0, I'm gonna let row 2 equal, and let's see, negative 2 row 1 plus row 2. So if I multiply row 1 by negative 2, that's a negative 2, negative 4, negative 6, and a negative 12. Row 2 is 2, 3, negative 1, and a 4. If I add those, I will get my matrix to become a 0, negative 1, negative 7, and negative 8. And if I want to make that a 0, I'll make row 3 negative row 1 plus row 3. That'll do. Negative row 1, negative 1, negative 2, negative 3, and negative 6. Row 3 now, second step, I want to make that a 0, but only by using those two rows. Well, if I let row 3 equal negative row 2 plus row 3. Row 1, row 2. Now, if I multiply this, well, those are obvious opposites. If I multiply one of them by a negative and add it to the other, one of an entire row 0 out. That means 0z equals 0, which means z could be anything, because this is always true. So z could be any number. I let z equal t. Some books use c. It doesn't matter. What's that? Any number that you want. You go back up just like we did in the previous problem. You say negative y minus 7. Instead of z, it's a t now. So my answers are going to be in terms of t. Since all of these negatives, I'll just swap those. I'll get 8 minus 7t equal y. Got y. I'll go to the first and I'll say x plus 2 times y. Y is 8 minus 7t. Plus 3t equal a 6. X plus 16 minus 14t plus 3t equal a 6. X plus 16 minus 11t equal a 6. So x would be 11t minus 10. So my solution would be, let z equal t, let y equal 8 minus 7t, and let z equal 11t minus 10. This is like me finding the general solution back when we did trigonometric equations. You want a solution? You could find an infinite amount of them. Let t equal 0. 0, 8, negative 10 would satisfy the first equation, the second equation, and the third equation. Meaning, in the first equation, replace x by a negative 10, y by an 8, and z by a 0 will get me a 6. In the second equation, it will get me a 4, and third equation, it will get me a negative 2. If I let x equal 1, 8 minus 7 is 1, and 11 minus 10, 1, 1, 1 seems to work. Plug 1, 1, 1 in the first equation, you get a 6. In the second equation, you get a 4, and in the third equation, you get a negative 2. So I could find an infinite amount of solutions by picking z to equal t. I just want to mention, that's how we're going to do things. You could let x equal t and do this, but this is the simplest way we could do this. So we're not after how many different ways you could do this. One way will do. Now, I do want to mention, if you write this in augmented matrix form, remember this stands for an equation. This I could write as is, or I could clear the fractions. I could multiply by 2 all of those if I want. If you see fractions, that make your life a lot easier. Now what? The goal, if I didn't pay attention to what's going on, I want to make that a 0. How do you do that? You would say, and if you see a shortcut, you could jump straight to it, but let's say you don't. Row 2 is going to be negative row 1 plus row 2. So if I take negative row 1, negative 2, negative 3, negative 1, and negative 5, 2, 1, negative 2, and a 7, and if I add those, that is 0, negative 2, negative 3, and a 2. So that will give me in the second equation a 0, negative 2, negative 3, and a 2. Row 1, the norm is that we don't play with it. How about the second? Well, if I take row 3, also negative row 1 plus row 3. Well, that's the same. That's not going to change. Now, if you did notice, but you're going to have to do this work anyways. Did you notice that those became the same, which means one of them is going to 0 out? Now, I could simply say, let row 3 be negative, let's say row 2 minus row 3. Well, since they're the same and now you're making one of them negative, automatically you could figure out that this is going to 0 out. And again, we're going to let z equal t. Negative 2y minus 3t equal 2. So negative 2y equal 3t plus 2. Y equals negative 3t over 2 minus 1. Of course, you're welcome to write 3t plus 2 over negative 2. It doesn't really matter. And the first equation is 2x plus 3 times 3t plus 2 divided by negative 2 plus z, which is t, equal 5. Solve for that and you're done. 2x minus 3 into 3t plus 2 plus t equal 5 over 2. If I clear the fractions, 4x minus 9t minus 6 plus 2t equal 10. It kind of messes up when you get to the side. 4x minus 7t minus 6 equal 10. 4x equal 7t plus 16, and x would be, again, either you say 7t plus 16 all over 4 or 70 over 4 plus 4. It makes no difference. So I got the x to be 7t plus 16 divided by 4. Again, t could be any number. Let t equal 0, you can get a solution. Let t equal 2, you can get another solution if you want. The book doesn't ask for that. Normally they just want the general case, and there it is. And how about this problem? Well, again, the same deal. One, two, 1, 2, 3, 1, 3, negative 1, negative 4. I messed up on the spacing. 6, 4, 1. Well, first goal is to make that a 0 and that a 0. So if I let row 2 equal, let's say, negative 2 row 1 plus row 2, that will take care of this. And if I let row 3 equal negative row 1 plus row 3, that will take care of the other 0. So if I multiply row 1 by a negative 2, that's a negative 2, negative 4, negative 6, and a negative 12. Add that to row 2. green. If I multiply row 1 by a negative 1, that's negative 1, negative 2, negative 3, and negative 6. Add it to row 3. Now, if I take those two rows and make that a 0. So if I take, let row 3 equal negative row 2 plus row 3, what would happen? Well, obviously, if I multiply this by a negative, that will become 0, 1, 7, and 8. Add that to 0, negative 1, negative 7, and negative 5. I'll get 0, 0, 0, and a 3. This last statement says 0 times z equals 3. That means 0 equals 3, but that's impossible. This has no solution. And those are the inconsistent systems. So, okay, inconsistent. Yeah, that works. So if you recall really quick, I'm going to talk about graphing two lines because 3D is kind of annoying. And here they only want 3D. When solving systems of equations, one of three things could happen. You can have two lines that have a solution. You could have two lines. Oops, wrong one. That are identical. Infinite solutions. That's those. And you could have two lines that are parallel. They never cross. That's the no solution case. I do want to give you just one warning. So we're done with this here. There's no solution. That's all you have to say. If you're looking at a matrix, so this is a note. If you're looking at an augmented matrix, just make sure not to make that mistake. If you see this, this says 1 times z equals 0. That means z equals 0. For some reason, students mix this with this. That's why I always write it, just to make sure that students don't make that mistake. And that's pretty much it for this section.